This den area has never had any lights, and in the evening it's kind of like a black hole. Everything will be lit up in the living room and then there'll just be this dark space. But today I'm going to change that with some recessed lighting. In the ceiling I'm going to install 2 recessed lights, and they're going to get their power from this switch over here. Except for what I need to do first is make this a double box. Right now it's just a single box with a single switch, and this switch actually goes to that light out there. I also know that the wire that comes into this box is old, so what I'm going to do is open it up for the double box, and then I'm going to replace the old wiring with 14-2 wiring, the wire that you use, the white Romex, the wire that you use for light circuits. So basically the power is going to come into the box, and then it's going to power this switch, which will power that light. And then there'll be another switch here, which will power the recessed lights that I'm going to install today. So first thing I'm going to do is make sure the power's off. I'm going to take the outlet out, and then I'm going to see which side of the stud the box is mounted to. So then when I put in my old construction box, I don't end up hitting a stud. So here's our 2 sets of wires. We have a wire that's going up to the light here, going up through the top of the box, and then a wire in the bottom that's going from the floor up to the box, that's powering the box. And I don't want to just cut off the wires that go to the Romex coming up into the box to power the box, because what I'm going to do is I'm going to hook a fish tape onto these wires, pull it down through the floor to where I can see the fish tape, hook my 14-2 Romex to it, and then pull it up into the hole. So there isn't a stud over here, which means it must be connected to this stud here. So I'm going to put my box right here. This is an old construction box. What it does is, instead of having nails that actually attach to the studs, it just has these little flaps. So then what will happen is the flaps will be down. You'll cut your hole in your drywall. You'll set this into the hole. And then as you screw the screw in, these tabs will stick up and hold the box to the drywall. Be very careful when you trace out where you're going to put this box, because there's going to be some obstacles here, but you want to make sure that these tabs sit on the outside of the drywall. In my last video I did a review of this borescope from VEVOR, and we had mentioned that we're going to be using this for this project, and I'm about to show you what I'm going to use it for. And this is definitely going to help us with fishing wires through the walls, seeing what's going on behind the walls, seeing if the wire is stapled, the old Romex is stapled, and what kind of obstacles we might have that we need to work around. So looking down inside the wall, I can see that this Romex isn't stapled. This old, it's like first generation Romex, it isn't stapled. So I'm going to hook my fish tape on to this old Romex and pull it down through the floor into the basement that's below this room here. This is a fish tape, just has rigid metal, and this one I think is 50 feet long. Make sure that when you connect the fish tape to any wire, make sure there's no jagged edges or anywhere for anything to get caught. So I'll usually take the electrical tape up maybe about another inch past where the end of the fish tape metal is. So I'm down here in the dungeon, that's our farmhouse basement, and here is the wire that I'm going to be replacing. And just so you know, I didn't do any of the framing down here. They must get all their lumber from IKEA or something. So I'm going to run the wire where they had it for the most part, but what I want to watch for is stuff like this. Right where they had the wire going up, there was a nail, so I don't want the new wire rubbing on the nail, so I'm going to at least bend that over. And I'll just kind of follow where they had the wire before. So now we have two wires. This will be the wire that feeds the power to both switches. And next we have the really difficult wire where I'm going to have to drill a hole in that top plate and fish a wire from here to go up to the lights. So if you watch my framing videos, you'll know that the way these walls are framed is they're kind of framed out with studs and a top plate and a bottom plate. And then there's actually another top plate that goes around the top to hold everything in, to hold all your walls and everything together. So what I need to do is actually need to drill through two, hopefully they're 2x4s. And what I'm going to be using is this bit here. So the way this works is it has a screw head on it. So this will actually start digging into the metal and working just like a screw and pulling the bit through. So what I'm going to do is go on the lowest speed, and this screw is going to be biting into the wood as this part, the bit, cuts. And so what I'll do is I'll go in a little ways and I'll just stop and back it out a little bit and then keep going kind of like up and down just to make sure that I don't break this bit off. I have a welder, so if something happens I'll just weld it back on, but some people, this thing got mixed reviews, and I'm guessing some people just got way too overzealous and broke it. So this bit will bend a little bit, so I'll be able to put it up through the wall and kind of stick it in the top plate where I want it. It actually doesn't bend as much as I thought it would, but I'm going to give it a shot here. So thanks to my handy borescope, I kind of see that there's a top plate there, and then there's actually some other type of thinner wood there. So I don't know, hopefully this isn't too bad to drill through. Like I said, I think that they got just a bunch of different types of scrap wood to build these. Alright, well I'm going to try to miss this far edge and hit more towards the middle. What's also nice about this too, if I can position this around, is I can actually see my other wire that goes over there. So I can make sure that I don't hit that wire. I don't put this drill into that wire. So if you watched the last video, you'll know that I drilled these little test holes in here, just big enough to get the borescope camera through. And all I'm going to do is go through a little bit of drywall mud on the ones that I won't need, whatever ones will be out of place. So what I did here is I used the front camera to get through the hole. And now what I can do is I can use the side camera, look around here, and it doesn't look like there's anything really in my way. There's a little bit of framing there and there, but I think I can avoid it. So I'll go ahead and get some holes drilled. Definitely over-engineered. So what I'm going to attempt to do next is feed this wire through the hole I drilled in the ceiling. It's not too far, and I'll just use this to hopefully guide me, and maybe I'll get the wire in there. We'll see what happens. What I actually ended up doing is I drilled the first hole straight, and the way my roof is, it comes up at an angle, so my fish tape kept getting caught. So what I did is I actually took it and drilled another hole up at an angle, so I was actually able to move past. Then I used the borescope to go up and see where the hole was, get the fish tape up to the hole, feed a bunch of it up, use the borescope to look through, up into the ceiling, figure out where it's at. Then I had a little hook that I used to pull it over. It's getting pretty late. Those wires took me a little bit longer to fish than I wanted to. This house is really goofy. You saw the 4 layers of the ceiling and some different things that they did down in the basement. So it took me a little while to get it fished through. Hopefully tomorrow I'll be able to finish up. Well, it's day 2 of the light circuit installation. So what I'm going to do first is repair a little bit of drywall where the box is going to go. And then I'll go ahead and start hooking up these lights first, and then get everything connected to the box, and then go downstairs and get it connected into the panel. So I'm going to start by putting some drywall mud in this area here. I'm going to be using the Easy Sand 5. It sets up really fast and it's pretty hard. And why I want some mud here is when I put that old work electrical box in, the tabs are going to need to hold against that mud. These are the recessed lights I'm going to be installing. The box is actually separate from the light. So what I'll do is take out these knockouts. If you've seen the channel before, you'll see the connectors that I'm going to use. They're the plastic connectors. And so I'll take the knockouts out, put the plastic connector in, and then feed my Romex inside and make my connections. And in the end light, obviously only have the one wire, and then the middle light will have a wire coming in, have the Romex coming in from either side. Once I'm done connecting the Romex, then these are pretty simple. They just plug in and twist. Metal's pretty flimsy on these boxes. So that'll be my end one. This will be the middle box. So I'm sure some of you are wondering why the wires are just kind of laying in place, and that's just kind of the nature of rewiring houses. Obviously you're not going to be able to staple anything in place, and a lot of these connections, these connectors that you're going to use, and especially I'm going to show you the box here in a little while, it actually holds the wires pretty tight, and so it's just kind of the best you can do when you have to go back and do rewiring without tearing out the walls. Something I should mention as well, when I strip that outer jacket, I'm just barely scoring the jacket pretty close to where it comes into the box out to about 3/4 of an inch to the end, and then I'll cut it deep because I'm already going to be stripping off the coating of the wires, so it's no big deal at that point. Obviously you don't want to nick any of these wires past about 3/4 of an inch in, just in case they would conduct. And you can see with this box as well, I didn't leave a whole lot of wires inside, but you see how much wire I have left to kind of play with here. And so whenever you're doing rewiring like this, make sure you leave yourself a little bit of room in length to the box. And then when you're inside the box, keep in mind you're going to have to put the wire nuts and all those wires back in that little box, so you obviously don't want to leave too much wire sticking out. Wire nuts are color coded, so you know what size of wire and how many of each wire you can use per wire nut. So I'm using these yellow wire nuts because they'll be fine for 3 of the 14 gauge wires. So with this old construction box, it has these, they're kind of knockouts here. You'll knock this tab in and you'll put the wire through, and then if you try to pull back on that wire, this tab will actually grab that Romex and won't let it pull out. And so this is why these are so effective and why you can just pretty much mount them to the drywall. And if you get everything cut out properly, get all your tabs in place, and then you screw in these tabs to hold against the wall, these are actually pretty solid. So at this point, you're going to want to treat these wires just like any other wires in a wall. So leave 6 or 8 inches sticking out so you can make your connections. The bad thing is when you go back and do old work, something like this will happen. You don't have a lot of length here. And if this was just a single box and I was dealing with this, I would actually take either some wire nuts, or if you've seen the channel before, those connectors, which I'll use on this to pigtail, I'll show you the connectors. I would actually just put single connectors on here and put a black wire sticking out and a white wire sticking out. And of course this also doesn't have a ground, which for lighting is not a big deal. There's a lot going on here, and I'll try to explain it the best I can. So essentially, these wires need to make a complete circuit. And what you do with this Romex, and especially if you haven't seen my electrical basics video, I'd probably watch my electrical basics video before maybe getting too far into this. But essentially what you're doing is you're bringing power from the black wire up to your device, and then the current is going to travel back to the panel box through your neutral wire. And then if something happens to your neutral wire or something becomes discharged that's dangerous, your ground wire will take it back to the panel box safely. And so think of it as the black wires bring the power out of the panel box. We're going to have switches here between the black wires that are going to break the black wires. And then you're going to run the power up to the light, and then through the neutral wires coming back, the current's going to go back down to the panel box. And so when I hook this up, just kind of try to follow the logic. So of course I have the Romex coming up from the bottom, which is obviously going to provide the power from the black. And so with that being said, this white wire is going to do nothing but carry the current back to the panel box. So obviously we don't want the circuit complete all the time, and that's why you put in a switch. And so if you want the switch, if you want the light to be on, then you want the circuit to be complete. So that means that your power would come out of the black wire, up through the switch, up to your device, come back down through the white wire, and then go back to the panel box through the white wire. So with that being said, what we can do is we know we can already connect all of the white wires together, because these aren't going to dictate if the current is on or off. The switches are going to dictate if they're on or off. And you connect the black wires to the switches. And so they're going to be the ones that actually break the circuit. And so at this point, we know that all the white wires can get connected. So this is the connector I'm going to be using. They're clear, so you know if the wire went all the way in to the connector. And there's these metal tabs that as soon as you push the wire in, they'll grab a hold of the wire and they won't let it come back out. I've never had an issue with these. I don't know if people like them or don't like them. I started using these a couple of years ago, and this is pretty much all I use when I can. These are single pole switches, and what that means is there's two screws where you'll connect one black wire and you'll connect another black wire, and the switch will break the circuit. So as the power comes up from the panel box, it'll go to one screw, and if the switch is on, it'll allow current to go through the other screw and complete the circuit. So let's leave out these black wires for now, and let's talk about this ground screw. So what I'm going to do is I'm going to use a piece of copper, and I'm going to connect it to this ground screw, and then I'm going to connect all of the grounds together. Of course, this old Romex doesn't have a ground, but I'm going to connect these up. And so what this does is this now provides a ground coming from the panel box and grounds all of this metal here, and then it's going to ground up to the lights. So once all of the grounds are connected, now essentially you have a way for any external power to go from any power that's out of the circuit between the hot and the neutral wires to make it back down to the panel box. So this is my pigtail, and something important with screws, whether it's the black wires that I'm going to put on these screws, or the neutral wires for an outlet, or this ground wire on this ground screw, you want to make sure you loop the screws around clockwise, because these screws turn in clockwise. And so as you turn the screw clockwise, it'll actually grab the wire and help tighten down against the metal of the switch. So I have 4 ground wires, a pigtail on each one of my switches, and the 2 wires here. If I did have another wire, like if you were running only wire, and this wire had a ground, you'd actually have 5 wires. You could either use a large wire nut and wire all 5 of them together, or here's a connector that has 4 slots. And so what I would do is I would connect, say like 1, 2, 3, and then use a jumper to another connector, and then plug the other 2 in here. Now we're at the 3 black wires. So this is the wire that comes up from the floor. So now we need to transfer power to each one of these wires here to go up to the light. And of course the circuit will be broken with the switch. So if I only have one wire coming up, how do I get the power to either switch? And how you'll do this is, once again, with these magic pigtails. And just for good practice, put the power that comes up from the floor on the bottom screw. So once again, we're going to hook it clockwise. So now when I tighten that down, it's going to tighten clockwise. And then I'll go ahead and use a connector to hook to this wire here. And it'll be the same way with this switch as well. So now with this connector, I have the power coming in and then the power going back out to each switch. Now I just need to connect up these other 2 wires, and then that'll allow the power to come in from the panel box up to the switch. As long as the switch is on, power will go up and power the light, and then the current will go back down through the white wires into the panel box. So this is all the further I could get that wire out, so it's going to be really difficult to get that around a screw. So I'll just show you what I was talking about earlier, just kind of extending this wire with a pigtail. So all I'm going to do is make this pigtail, or all I'm going to do is connect this pigtail, and this red connector is just a 2-wire connector. So I have it connected to the black wire, and then I'll just kind of tuck it back in the back. And now I have plenty of length to connect it to the screw. So I know this kind of looks like a mess, and when I push everything back in here, it's going to be a lot neater. But you see how the ground wire is just kind of here in the way? And then if I just went and pushed this back, and as I was pushing this back, if something was able to touch, then obviously you're going to be shorting out a circuit. So what I'm going to do is I'm going to be wrapping electrical tape around these screws, so it's going to act as an insulator. But when I push all this back, I'm still going to want to try to get these ground wires clear back to the back, and then go ahead and put these black hot wires in front of it. So if you want your install to look really professional, make sure that these little boxes fit inside your cover really well. And if they're sunk too low, they actually make spacers that can go in behind the switch here, between the box and the switch, that you can actually move the switch out just a little bit. So if you can get something that looks about like that, that's pretty respectable install. You don't have to put all the screws going up, but I usually do. Just put them all vertically or horizontally. I know it doesn't seem like it makes a difference, but I've actually had customers saying, oh yeah, that looks really nice, you put all the screws going the same direction. So you can see the little bit of a mess I made. Kind of put some marks on the wall, and then of course I have the drywall that I use to shim out the box. And so I'll come back after I get done with everything and prime the little bit of drywall and paint it. So there's the wire that comes down from the upstairs box. So all I have left to do now is connect it into the panel box. Eventually I'm going to staple that Romex wire coming across to that floor joist, but I'm not going to do it right now because my baby's sleeping. And so I'm just going to come down to the panel box with one of those Romex connectors. So let me just take a quick second to tell you that this is going to be the most dangerous part of the install, messing with your main service panel. If you have a super old house, there's a chance you maybe only have a 60 amp entry, maybe you still have fuses. This is a 200 amp entry, and so certainly it'll end your life pretty quick. And so it's something that definitely needs to be understood, even if you want to do this part of the install yourself and then have a licensed electrician or somebody you trust come over and do it. This is the part where you certainly want to be as careful as possible. So up at the top of your panel box, or down at the bottom, you'll have your main shut off. Mine's up here at the top because of where our power comes in. The old circuit had a 20 amp breaker on it. That was actually bigger wire too, the wire that was used for that light. So it was actually a 12 gauge wire, so it's 20 amp wire. So since I'm going to be installing this 14.2 wire, 14 gauge wire, then it can only handle 15 amps, only rated 15 amps. So I'm going to be putting in a 15 amp breaker. So once again, every time I'm stripping this Romex wire, I'm just gently running the utility knife along it to score it. And then towards the very end, I'll make my cut all the way through. And then it just peels right off. So these are your bus bars on the sides. Whenever you connect your wire into the bus bar, you want to make sure that it sticks just past the bus bar so you can see it, and then tighten it down pretty snugly, and then just make sure it's in there pretty tight. Unfortunately, I didn't have a GE breaker laying around. I have another brand. It fits. A lot of them are interchangeable. Some of them are not. So make sure that if you're going to use one, that it's compatible with whatever box you're using. This will bug the heck out of me and keep me up at night. So I will definitely be switching this out. But when I switch this out, obviously I don't have to disconnect the neutral and the ground. All that I'm going to be doing is connecting up this black wire today. And then if I want to change this out, all I have to do is turn off the power, disconnect this from the breaker, pull out the breaker, put in the new breaker, and hook this wire back up to the new breaker, turn the power back on, and I'm good to go. Okay, I should have had that off when I installed it, but the power's off anyway. The house power's back on. So this is going to be a really good test to see if you did this right or if I did this right. I'm going to go ahead and turn this on. If it's short circuit anywhere, it's going to trip immediately. So it's staying, so there's no short circuit, it's not tripping the breaker. So I'm going to run up and go check the lights, and then I'm going to come back down. Obviously, if you have people in the house who didn't come stick screwdrivers and stuff in here, maybe put the panel box on first, or put the panel cover back on first. Everybody in my house that would do that's asleep right now. And so I'm gonna run up, go test the lights, I'm gonna come back down and put the cover on. So you remember the test holes that I drilled in the ceiling just to see where the joists were and to get up there and see what was going on up in the ceiling, see where I could actually run the wires or if it was even possible. What I'm going to do, usually I'd throw some drywall mud on here, and I have spackling, so I'm just going to use a spackling because it's a textured ceiling and I just kind of want it to look rigid. So I'll come back with some ceiling paint and maybe a ceiling primer, and you'll never even know I was drilling holes in the ceiling. This is what the den area looked like before we put in the lights, and this is what it looks like after. It's also going to be nice to have this entryway light. This hasn't actually worked for a couple years. We rearranged some wiring and it's been disconnected for a while. So I'm glad this project's pretty much wrapped up. We've been wanting to do this for a while. Finally got it done, and thanks to VEVOR we found the borescope and kind of made this possible. We didn't really have an easy way to do this before, but the borescope made it pretty easy. And now we have some lights. I know my daughter's definitely going to like it, especially in the winter time. It's really dark here, and so she'll have a better place to play. So we appreciate you watching this video. Hopefully it's helped you learn a little bit more about how to wire circuits and put in lights, especially in difficult areas. And we look forward to putting out more videos to help you on projects around the house in the future.